Hello, in this video, we'll be looking at solving inequalities in one variable. So, solving an inequality is very similar to solving equations with one little addition towards the end of solving the problem, or in general. You will see in the process of solving inequalities, sometimes the inequalities will switch. So if it's a greater than, it can become a less than. So let's first look at the inequality symbol. So for the symbols, we have this one here, which is called greater than. Then we have this symbol, which is less than. Then we have this symbol here, which is greater than or equal to, right? Please make sure you read it in or. And we have this one here, which is less than or equal to. Okay. And then we can say that a linear inequality in one variable is any inequality that can be put in the form ax plus b greater than c. Okay. So notice if you have ax plus b greater than c, a cannot be 0, right? And here we have a where a, b, and c are constants. Okay. Some examples of this are as follows. We have 6 x minus 2 is greater than or equal to 7. Or we can have minus 3a is less than 41. Or we can have 2 parentheses x minus 4 is greater than 2x plus 3. So these are all different types of examples of inequalities in one variable, okay? Now, if we want to solve inequalities, so let's look at an example. How do we solve? Okay. So if we have 3x plus 3 is less than 2x minus 1. So that's what we want to solve. So 3x plus 3 is less than 2x minus 1. I always like to move the x first. So we're minus 2x, and smaller x's is what I use first, move first. So we have 3x minus 2x is x, the plus 3 comes down, less than the plus 2x and the minus 2x becomes 0, so minus 1. And then I will minus 3 on both sides, okay? So we have x plus 3 is less than minus 1. and then we minus 3 on both sides. And by doing this, we now have x, the plus 3 and the minus 3 becomes 0, is less than negative 4. So here we have x is less than negative 4. Now a big suggestion that I have is always read with the letter first. So the way we read this, x is less than negative 4. Okay, so this is our algebraic solution. Okay, this is the algebraic way of writing the answer. The answers, so answers of inequalities can be given or expressed in a few ways. Okay, answers of inequalities can be expressed in a few ways. We can also express this graphically. Okay, and to do it graphically, what we do is draw a horizontal line, which is the number line, really. Somewhere in the middle of that line we know is 0. Okay, somewhere in the middle is 0. Let's put it here. And then we have numbers to the right. Okay, and we have numbers to the left. Now, since we're going less than, so we have negative 1, negative 2, negative 3, negative 4. It's less than, so the arrow will be pointing towards the left. And I'll draw that in. Okay. However long you choose to make that arrow, that all depends on you. Now we use a parentheses because the inequality is less than. Okay, we use because it is less than. So note, okay, when we have an inequality with the symbol less than or greater than comma, we will use either an open parentheses or a close parentheses. Okay, or we can use a open circle or a shaded circle, okay, on the graph. So this is a matter of choice, whichever way you were taught this, okay? So for this lesson, we will use parentheses and brackets, okay? So for less than or greater than, we use parentheses, okay? We'll see what we use when it contains the or equal. So another way of writing the answer is interval notation. So interval notation. Now, when you write interval notation, the graph helps a lot. And you always look at the graph and the arrow that you drew start from the left, either whatever you draw, start with the left side first. So if you look in this graph, the left side here goes towards negative infinity. So we can write this as negative infinity, and infinity always has a parenthesis. So negative infinity, comma, and then where does that parenthesis end? So that parenthesis ends at -4. And since it's contained the inequality without the equal, we use parentheses, right? Parentheses. We can also write our answer in what is called set notation. Okay. And remember, the equation is an equation of the variable x. So we write must be in curly braces x such that x is less than -4. So this portion here is really your answer, okay? And this portion of that inequality tells you the variable that's being used in the equation, okay? So there are four ways we write our answer, okay? 4 ways we see. So you must know for my lesson that we write the algebraic, the graphical, and the interval. I do not stress so much on the set notation. Let's look at another example. Solve. And here we're giving -2a minus 3 is less than or equal to 7. So -2a minus 3 is less than or equal to 7. So notice my inequality is less than or equal to now. So we start off by moving a's, but there's only one term with a, so I move straight to the -3. So I will add 3 to both sides. And by doing this, we'll be left with -2a, the -3 and the +3 cancels, and this becomes less than or equal to 10. So we have -2a is less than or equal to 10. Now, here's the little change in your inequality. So notice now I am going to divide by -2. And whenever you divide by a negative number, that inequality sign will now flip. Okay? That inequality sign will flip. So I'm left with the -2 divided by -2 becomes positive. So we have a, but the inequality sign now becomes greater than or equal to. Okay? And 10 divided by -2 is -5. So the rule, the little rule here, okay, rule, whenever you divide or multiply both sides, okay, by a negative number, the inequality sign, we say flips. Okay? And what do we mean by flip? It changes direction. So here is our answer. Okay. Now, if I ask you for the graphical representation of that, graphically, okay, that will look the number line. Remember, anytime we graph the answer, it's on the number line. Somewhere will be 0. On this side will be some positive numbers. And generally, I don't write the numbers in, okay? I don't write the numbers in. I just put a -5 here. Now, it's greater than or equal to. So now, because the inequality sign greater than or equal to, we use a bracket. So anytime the inequality includes the equal to symbol, okay, for greater than or equal to or less than, we use brackets, okay? So let me rewrite that. So a little note, when we graph greater than or equal to or less than or equal to, we use either open brackets or close brackets, okay? So we use brackets, and then it's greater than, my arrow will go towards my right, okay? Arrow will go towards the right. Now, the interval notation for this, interval notation, now notice that we start from the left. So what we write is a bracket first. Then it's a -5, comma, and then that arrow keeps going on and on and on. So that goes to infinity, okay? 0. And remember, infinity always gets parentheses. And then if you're asked for the set notation, the equation was an equation of A. So now we have A, so open bracers, A, such that, and our answer was A greater than equal to -5, right? A greater than equal to -5. So A greater than or equal to -5. We close with a curly bracers, okay? So your answers in interval notation can have parentheses, brackets, both parentheses, both brackets. So let's look at some of the notation, interval and graph, okay? So now we want to look at examples of inequalities or inequality notation, intervals notation, and graph. So let's look at this. We have here inequality, then we have interval, and then we have graph, okay? So the first inequality that I have is if we have an example x, so this is the first one, less than 3. So the interval for this, or maybe I should switch the order. Let's switch the order. Let's do the graph first, because from the graph, it's easy to see the interval, okay? If we look at the graph of this, so let's say here is 0, somewhere here is 3, and for less than 3, okay, the arrow will be pointing towards the left. And it doesn't matter how far in the number line you go, once it's visible. And then your interval here will be -infinity, comma 3. Yeah? -infinity, comma 3. And you will see that when both ends of the symbol uses parentheses, this is called an unbounded interval. Okay, unbounded interval. So an inequality interval has names also. Okay? We'll write that out in a minute. The next scenario we have is if we have x is less than or equal to 3. So on a graph, so here is 0 and here is 3. Now it's less than or equal to 3, so we use a bracket, and that will go towards the left because it's less than. Okay, brackets towards the left, and you can go past 0, it doesn't matter. Okay, and this becomes minus infinity comma 3 brackets. Okay, brackets. We also have other scenarios where x is now, let's say, greater than 5. So if we look at a number line for that, so here is, let's say, 0, 5 is, let's say, out here, greater than, no equal. So we'll use parentheses, okay? Parentheses, and the arrow will be going towards the right. So now the parentheses is first, 5, and that arrow goes towards infinity, and infinity always have a parentheses next to it. And then we have what happens if it's greater than or equal to 5. Well, similarly, if this is 0 and here is 5, because it's greater than or equal to, now we use brackets, and that arrow will be going towards the right. So here we have, here we have bracket 5 comma infinity. Okay, so the names, okay, the names, when we write an interval, we can say it's bounded or unbounded. So intervals can be bounded or unbounded. Okay, intervals can be bounded or unbounded. So if we look at the first one, right, the first example as we did here, our first example, minus infinity comma 3. So if we have minus infinity comma 3, and that was also a parentheses, when both end has parentheses, okay, then we say this is, and keep in mind, or we can say x is, that we have, yeah, the inequality was x is less than 3. And this here is unbounded. Unbounded. The reason we say it's unbounded is because both ends have parentheses. Okay, there is no boundary. Okay. The next example we had was, we had negative infinity. So we had negative infinity comma 3 with a bracket. Or we said x is less than or equal to 3. And we can say when one end has a bracket, we say this is bounded. Bounded. Okay? And The next one we have is both ends again parentheses. Okay, so if both ends are parentheses, we know it's bounded. Now we can also have scenarios where we have both ends with brackets. Okay, both ends with brackets. So for example, we can have 0, 4, or we say x is less than or equal to 4, greater than or equal to 0. And when this is also called bounded, because both ends has brackets. Okay, it doesn't matter which side the bracket is on to, right? We can also have this scenario where 4, infinity, or oops, so we should write it. We can have bracket 4, infinity, or we can say x is greater than or equal to 4. And when this happens, this is also bounded. So basically, when you write the interval, if you see any sort of bracket, it's bounded. If there's no brackets at all, it's unbounded. Okay? Yeah. So those are some things you may hear these words bounded versus unbounded as you solve. Okay? So let's look at some more examples. Solve. If we have 3 parentheses 2x minus 4 minus 7 in the outside of the parentheses, less than or equal to minus 3x. So we always look for like terms before we do anything. There is none. So we have 3 parentheses 2x minus 4 minus 7x is less than or equal to minus 3x. Okay, so the first thing we're going to do, since there's no like term, we will distribute the positive 3 to inside the parentheses. And by doing this, we have 6x minus 12 minus 7x is less than or equal to minus 3x. Okay. And then what I will do is combine like terms. So here we have like terms. Combine like terms. And if we do this, we end up with minus x minus 12 is less than or equal to minus 3x. And I move the x now to the other side. So we add x to both sides. And by doing this, we get minus x and the plus x will become 0. So we have minus 12 is less than or equal to negative 2x. Okay. So now to get x by itself, we have to divide by a negative. Divide by a negative. Okay. So remember, anytime you divide by a negative, that inequality sign will flip. So now we have positive 6, okay, greater than or equal to, the sign flips. So notice here, inequality sign will flip because we divide by a negative. Okay, that's why it flips. And then negative, and the negative becomes positive x. Okay, this will cancel out. So, or we can write this as x, okay, is less than or equal to 6. Okay, these two things are the same. Okay, these two things are the same. So, how do we write this? as an interval. So let's see if we can write it interval before we do graph. Now x is less than 6, okay? So that means if it's less than, it's going towards the infinity side, negative infinity, right? Because less than will be 5, 4, 3, 2, 1, and so on. So that means we have parentheses, negative infinity, comma, 6. But notice the inequality here contains the equal sign. So here it's a bracket. So this is a bounded interval. And then graphically, we draw the number line, okay? Somewhere here is 0, 6 will be on this side here, and then I use a bracket, and it goes towards the left. Okay, so this will be our graphical representation. So you have to be familiar with the different ways to present the answer, right? Interval, graphical, set notation, okay? Let's look at another example. Let's solve. And let's look at one with a fraction now. So 9/5 is greater than minus 1/5 minus 1/2 x. Okay, so we have 9/5 greater than minus 1/5 minus 1/2 x. So let's get rid of the fraction, right? Let's get rid of the fractions. And by doing this, you kind of like feel less relief. You're already stressed with solving a problem. You don't want additional stress, okay, or frustration. So what we'll do, we find the lowest common denominator. And the lowest common denominator of 5 and 2, that will be 10, okay? And what we do next is multiply, okay, multiply each fraction by 10. So we have 10 times the first fraction we have was 9/5. Okay, that was greater than, then we multiply by 10 again. 10 times the next was negative 1/5. Okay. And then we had minus, and we multiply again. 10 times 1/2 x. Okay. So by doing this, the fractions will cancel out, right? So 10 divided by 5, that becomes 2. So 2 times 9, that is 18. Greater than, we do the same thing again. 10 divided by 5, that's 2. 2 times negative 1, and that becomes negative 2. Minus 10 divided by 2 is 5, and 5 times 1 times x, okay, that becomes 5x. Okay. So the next step, now I notice I don't have any fractions, right? I don't have any fractions. So I'm gonna start solving now. So I add 2 to both sides. And here we have 20. Okay, well, that's 20 is greater than the minus 2 and the plus 2 cancel. Minus 5x. And now we want to get rid of that negative 5. So we must divide both sides by a negative 5. And once again, you divide by a negative, my inequality sign will flip. Okay, so sign, inequality sign must flip. Okay. So if you do this now, we have 20 divided by -5, that becomes -4 is now less than x. Okay, -4 is less than x. Or we can say that x is greater than -4. These two things are the same answer. Okay. So it is always suggested when you read with the letter first. So this is a suggestion. Okay. So we're gonna read as x is greater than -4. Okay. And what is my graphical solution? If you're asked for the graphical solution, so here is the number line. Here is 0, -4 is somewhere over here. X is greater than -4, so we don't use any brackets, we use parentheses, and that parentheses will go towards the right, okay? X is greater than -4. Now, if I ask for the interval notation, for your interval notation, okay? Remember, we always write whatever comes first in the graph, so we write parentheses, okay? -4, comma, and that arrow goes all the way to infinity, and infinity always get parentheses. So this here is an unbounded interval, okay? Unbounded interval. So your only concern is when you divide here or multiply both sides by a negative, right? When you divide or multiply both sides by negative, okay? Now, there is also something called compounded inequalities, okay? Compounded inequalities. And a compound inequality, okay? So we can say this is when, okay, this is when we have an inequality with, or an inequality with two symbols. And what do I mean by that? Example, we have -2 less than or equal to x minus 5 less than or equal to 2. So notice we have two inequality symbols, right? Two inequalities. That's what we mean by the two here, okay? So when we have more than one, well, we usually only have two, we call it a compound inequality. So a suggestion is when suggest, because you don't have to do this, when you see such a problem, okay, you should create two inequalities. Okay. So let's see, what do we mean by this? Suppose I ask you, example, solve. And I gave you -2 is less than or equal to x minus 5 less than or equal to 2. So what we do, we will start with the first left side, right? The left side first. So this becomes minus, that's -2 less than or equal to x minus 5. Okay. And then what I do is look at this portion here, and that becomes x minus 5 is less than or equal to 2. So in this way, at the end, we'll put them back together, okay? We'll put them on one graph. This is one way of doing it. You don't have to do it this way, but this is just one way of doing it. And the reason I do this is because you know how to solve both of this now, right? You can solve 2 is less than x minus 5, and you can also solve x minus 5 is less than 2, okay? So if you solve here, we will add 5 to both sides. We add 5 to both sides. And if we do this, we end up with 3 is less than or equal to x, and the -5 and the +5 become 0. So the way we read this as x is greater than or equal to 3. Okay? This is your answer, or this one here. I always like the x on the left side first when I read it. Now, in the next case, what we will do is we will add 5 and add 5. And when we do this, we end up with x, the -5 and the +5 become 0, is less than or equal to 7. So this is your answer, okay? The x is already to the left, so now, if you graph this one here by itself, if you graph this by itself, somewhere here is going to be 0, 3 is to the right, and it's greater than or equal to, so this will go towards infinity, okay? If we look at the other graph, if we look at this graph here, okay, here is 0, somewhere to the right is 7. And since it's less than or equal to, that will go towards the left. So notice now, if you combine these two graphs, if you combine them, we will get a graph where one arrow will be going towards the right and one arrow will be going towards the left. So let's say here is 0, here is 3, and here is 7. Okay. Now for 3, we have this, and that arrow is going this way. And for 7, we have a bracket, and that arrow is going this way. Notice the arrow is always pointing in opposite direction, and that will be the case, okay? This will be the case. So in an interval now, so this was graphically, okay? And interval, we will have bracket 3, comma 7 bracket. So this is bounded, okay? This is bounded. Okay. Let's look at another example. Let's solve. If we have -60 is less than 50 a minus 40 is less than 60. Okay, so minus 60 is less than 50, a minus 40, and that's less than 60. So let's split it into two. On the first part, I will take this side, which is minus 60 is less than 50a minus 40. So that's this portion here. Okay. And then on this side here, I will take this portion, which is 50a minus 40 is less than 60. Okay. And now we can solve both of these individually. Okay. So let's solve. Okay. Minus 60 less than 58 minus 40. And then we'll solve this one here too. So my goal is to get a. So what I'll do, I will add 40 to both sides. Okay. And if I add 40, we have minus 60 plus 40 becomes minus 20 is less than 50a. The minus 40 and the plus 40 becomes 0. So we have minus 20 is less than 50a. And then to leave a by itself, I'll divide both sides by 50. So we didn't divide by a negative, so no inequality sign will flip. So we have minus 20 over 50 is less than the 50's cancel, a. And notice we can simplify, okay? We can simplify. So we have minus 2 over 5 is less than a. Or we can say a is greater than minus 2 over 5. Okay, so here is our answer. Now, if we look at the other side, we're going to add 40 again to both sides. So we add 40, and we add 40. And if we do this, we're left with 50a, the minus 40 and the plus 40 cancels out, is less than 100. So we have 50a is less than 100. And then we divide both sides by 50. We divide both sides by 50. So that leaves us with 50 divided by 50 is 1. So a is less than 100 over 50. And once again here, we can simplify. Okay. Simplify. So we have a is less than 2. That's 100 divided by 50 is 2. So a is less than 2. Okay. So now if we graph this, okay, and we can combine, okay, we can combine these two if we want. We can write as 1, okay? So let's write a is less than 2, and this here is really a is greater than negative 2 over 5. So if you want to write it as 1, that will be your answer, okay? So notice this piece goes here, right? And this piece goes there. That's basically what's happening. Okay, graphically, okay, if we have our graph, here is 0. We know 2 is going to be somewhere over here, and minus 2/5 is going to be somewhere in this side, right? We don't really care exactly, and that's why I don't put any other numbers. Once we know negative is on the left, that's fine. Now it's greater than, so we use parentheses, and if it's greater, we always go towards the right, okay? and a is less than 2, so we always go towards the left when it's less than. And notice I can just join them together. Okay, so my interval notation, interval will be from -2/5, comma, 2, close parentheses. So this is unbounded. If we look at one more example, let's solve. We have -1/2 parentheses 2x plus 1 minus 2 is less than or equal to -3/8 parentheses x plus 2 plus 4. Okay, so we can either, well, let's rewrite it first. -1/2 2x plus 1 minus 2, and then -3/8 times the parentheses x plus 2 plus 4. So I always like to distribute first before I get rid of the fraction. And that's because sometimes when you distribute, the fraction goes away. So let's see when we distribute what happens. -1/2 times 2x becomes minus x. And then -1/2 times 1 becomes minus, okay, 1/2. And we bring down the -2. Less than or equal to, if we distribute again, okay, -3/8 times x, that becomes -3/8x. And then we distribute again, -3 times 2, that becomes -6/8. And we bring down the plus 4. Now, so I'm going to write every term as a fraction, right? So write all terms as a fraction. If I do this, I end up with -x/1 minus 1/2 minus 2/1 less than or equal to -3/8x minus 6/8 plus 4/1. Okay, we can simplify. Okay, so that leaves me with -x/1 minus 1/2 minus 2/1 less than or equal to -3/8x minus 3/4, right? 3/4. I divide top and bottom by 2. Is it a minus I had or a plus? So let's do +4/1. Okay, +4/1. Okay. Now, to get rid of the fractions, let us get rid of the fractions. So we do that by finding the lowest common denominator. And the lowest common denominator of 2, 8, and 4 is 8. Okay. So now we multiply, okay, multiply each term by 8. Okay, we'll multiply each term by 8. And to do this, we have 8 times, okay, -x, let's write it closer, -x/1, okay, minus 8 times 1/2, minus 8 times 2/1, okay, less than or equal to, let's write this properly, 8 times minus 3 over 8x minus 8 times 3 over 4 plus 8 times 4 over 1. Okay. The reason we're doing this is to remove those fractions, right? We want to work without fractions. So there is nothing to cancel in the first case, so this becomes minus 8x. The 2 and the 8 becomes 4, so this becomes minus 4. There's nothing to reduce the bottom, so this becomes minus 16. Okay, less than or equal to, the 8 and the 8 will cancel out, so this becomes this times that. So this becomes 1 times minus 3 times x is minus 3x. The 8 and the 4 becomes a 2, so here we have minus 2 times 3 is 6. There's nothing to this, for 4 times 8 is 32. Okay. Now we have like terms, so we'll combine like terms. And over here, we combine like terms. So if we do this, this becomes minus 8x minus 20 is less than or equal to minus 3x, okay? And negative 6 plus 32 becomes positive 26, okay? Now we move the smaller x's, so we have minus 8x minus 20 less than or equal to minus 3x plus 26. So if we add 8x to both sides, okay, if we add 8x to both sides, the minus 8x and the plus 8x become 0. So we have minus 20 is less than or equal to minus 3 plus 8. That becomes positive 5x plus 26. So minus 20 is less than or equal to 5x plus 26. Now I'm going to subtract 26 on both sides, okay? And if I do this, this becomes minus 46 is less than or equal to 5x plus 26, and minus 26 is 0. Okay, so now we have minus 46 is less than or equal to 5x. And what I do now, I divide both sides by positive 5. So we end up with minus 46 over 5 is less than or equal to, this becomes 1x. Or we can write this as x is greater than or equal to minus 46 over 5. Okay? X is minus 46 over 5. Now, if we graph this graphically, okay? So graphically, remember, I always put 0 somewhere in the middle, and negative will be on the left side. So anywhere on the left side, once you don't put the numbers in, and it's greater than or equal to, so bracket, and that will be going towards infinity. Okay. And if we wanted to write this as an interval, this becomes bracket minus 46 over 5, comma, infinity. So as always, you may want to even check your answers, right? Because it's very easy when doing algebra to make mistakes, okay? So it's a good suggestion to check your answers as you work these problems, okay? Even I could make mistake because we are concentrating on the video and making sure that everything goes smoothly. Okay? So please make sure you practice as many problems as possible. Okay. So I will stop here on this lesson and we'll continue again next time.